Well, thank you very much. I figured that this place would empty out after the bar closed, so I'm pleasantly surprised to see that everyone is here. This is a beautiful building, I must say. I hadn't been in here before. I would add, however, that probably not the best place to ride out a hurricane. Be pretty terrified in here. So today, this evening, I wanted to talk to you about the Great Storm and talk broadly about how, if we were to be faced by such a storm today, what that would mean for Galveston and Houston. The short answer is bad things. We'll talk a little bit about how prepared Houston is for hurricanes in 2025, the Houston region. And then if we have time, I'll talk a little bit about the best forecast model and what some of the cuts to NOAA's budget mean for forecasting for the rest of hurricane season, weather in general. That'd be great, thank you. Can't do it with one hand. So just a little bit about me. I studied astronomy in college. Thank you very much. Worked 17 years at the Houston Chronicle. My day job is to write about space, and I thought it was going to be that way until Hurricane Harvey, when Space City Weather went from a hobby to a second job. Like the Bryan Museum, we're celebrating our 10th anniversary this year, and actually in October, so it's gone by quickly. Been a lot of bad weather in those 10 years. And yeah, so we have a no hype philosophy, and we don't take ourselves too seriously. Some of you know, this morning's post was basically gifts. So we like to have a little bit of fun, but the Great Storm was not fun. So let's step back in time just a little bit to remind you of the numbers. I think what really surprises me the most is that there have been 400 tropical storms and hurricanes since then to hit the United States. And if you add up all of the fatalities from those storms, you still don't get to the number of the Great Storm of 1900. We're talking about sustained winds of 120 to 130 miles per hour, which I think really are unimaginable, especially if you didn't have like protection. A 15-foot storm surge, and at the time, the highest point on the island was not even 9 feet above sea level. So this was really, it had it all with the devastating waves and surge and the winds and 3,600 buildings destroyed. You can imagine how helpless it would be to be in such a situation and have nowhere to go, and it just continues to get worse and worse and worse. And it had impacts far beyond Galveston. These are some Houston coverage from the time, just talking about how there were impacts out in Katy, along the Santa Fe Railroad, Brenham, badly torn up. Lives lost in Dickinson. So this was a major storm in the Houston area, but even beyond the Houston area, this is from the Chicago Tribune, where they had hurricane force wind gusts as far as Buffalo. What happened actually is that the storm got absorbed in a pressure system, and basically that helped amplify its winds much farther inland. There's also some really interesting stories in here about relief trains being sent to Texas after the storm. So this was really a national weather disaster, and it was huge news at the time, obviously, because of the fatalities, but also just because of the utter destruction. A hurricane, this was really kind of an unprecedented situation, I think, as the nation grappled with hurricanes. So just to look back at the meteorology of the storm, and this is really important to understand why it caught people a little bit off guard. So when the storm passed over Cuba, it was a tropical storm, and it looked like it was basically heading northwest, right? So if you're in Texas and you've got a tropical storm moving north-northwest, you're probably not that concerned, and I'll talk about sort of the warnings that were issued in just a minute. But a couple bad things happened after that. One is that a high pressure system forced the storm, which they didn't name storms back then, so we just call it the storm of 1900, pushed it west, and then it must have gone rapid intensification because it quickly went from a tropical storm to Category 2 to a Category 4, less than 2 days later. So, we were basically, from a meteorology standpoint, flying blind. So just to give you a little bit of a tick-tock of what actually happened in terms of what the people knew. So the warnings, such as they were, after the Cuba landfall, were issued for Florida and the eastern Gulf states. So Texas had no hurricane or tropical warnings at the time. So, and if you were a ship out in the Gulf of Mexico, first of all, bad timing. But second of all, you had really no way to communicate that, holy crap, there's a hurricane out here, back to land. So there were you weren't like getting data from people who were out in the Gulf about what was coming. So most people probably know Isaac Klein. He was the head of the Galveston Weather Bureau, and he must have sensed pressures falling because he raised the hurricane warning flags a day before. On September 7th. And he did not have information, right, that a hurricane was coming. He was just sort of, his spidey senses were tingling, and he was seeing conditions that could indicate that storm that had hit Cuba might actually have turned this way. And so on the morning of the landfall, he's out on the beach, telling people to move to higher ground, 8 feet above sea level, I guess. I don't know. There wasn't much of it. And then that evening, sort of his chilling final telegraph, before everything was cut off, Gulf rising rapidly, half of the city now underwater. The city's population was 35,000 people, so at least 20% of the population died, which is a remarkable number. And his warnings, to the extent that he was able to get the word out, and this was a time before you had any electric communications, right? So it would have all been word of mouth or morning or afternoon newspapers that would have had some warnings, but certainly, no one was putting out credible information that people had to leave the island. So he was doing the best he can. So that was really, if you stop and think about it, 125 years later, how everything from a forecast and a communication standpoint, things have changed. And so we're in a much better situation today, right? Because we have satellites starting in the 1970s that can track storms, identify them, measure their size, and determine where they're going. And then when storms get a little bit closer to land, we send hurricane hunters into them to take very precise data. And this goes into computer models, both traditional physics models and newer AI models that take those initial conditions and then try to project forward what's going to happen. So that's airplanes, satellites, computers, all sort of inventions more recently. And then, of course, we have the National Hurricane Center, which disseminates warnings and updates every 6 hours in Miami, Florida, for the entire Atlantic Basin. And so, the result of this is that we have far better information about impending hurricanes. Katrina, that was actually one of the reasons why Katrina was such a striking event, is because there were so many deaths. It's rare for that to happen. But so while all of this, that's great, right? We have more information, much more timely. We have a lot more property along the coast. And so one of the things I want to talk to you about over the course of the next 3 hours is the vulnerabilities of Houston to a hurricane like 1900 today, when the population of the region development is just much, much greater. All right, let's see what's next. Oh, yes. So So we're going to get to that, but before we do that, I really want to talk about kind of just rehash what the three main threats of hurricanes are and talk about some recent examples so we can kind of understand what we really need to be concerned about with hurricanes. So the first one is inland rainfall. This is less of an issue on Galveston, obviously, right? Because the rain's heavy, goes into the Gulf or it goes into the bay. And that's, you don't have to worry about bayou flooding. But for the greater Houston region, like there's a deep appreciation, I think, for inland flooding because we had Hurricane Harvey. It's now been 8 years, which is hard to believe, but that really was a, fingers crossed, worst case scenario, I think, for flooding in this region. Not just the amount of rain that like locations got. We've had tropical systems that have brought 40 or 50 inches of rain before. It was the fact that there were 40 or 50 inches of rain across a huge area. So this is the extent, and I'm just going to walk over here and point of, so the yellow is 40 to 45, and then sort of this green area here. So everything green and yellow, so it's covering like parts of 6 counties, is 35 or more inches of rain. And my first real experience with weather in Houston was Tropical Storm Allison in 2001. Who all sort of experienced those rains? Like I was in Midtown at the time, and it was crazy. So that was like kind of like my reference point for worst flood in Houston, right? How could it be worse than that? So look at the area in dark green, right? That's 35 or more inches. And I'm going to go point at a dot that basically is of the area of Houston that received 35 or more inches of rain during Allison. It was about the size of this little dot right here. Now, it was up here, but same point. The point is that the rains from Harvey just were over this incredible area. And it's even 8 years later to me, it's shocking. I certainly hope we never see anything like that again. But, you look at like that big yellow area, and then you've got this area of 30 to 40 inches of rain inland of that. Imagine that all that water falling like over North Harris County, Chambers County, that all has to get down to the Galveston Bay and the Gulf, but there's this wall of water between it. It was an incredible thing to be. And there's a lot of words up there, but the basic conclusion is that we had never seen anything like this in 140 years of rainfall records. And it was crazy. Another thing is like that I saw, if you looked at the rainfall over like a 10,000 square mile area and looked at all the other rain events in the continental United States since we've been taking measurements, the record set by Harvey for that amount of rain would be like if someone hit 108 home runs in a Major League Baseball season this year over the current record. But it absolutely smashed it and was unprecedented. So Space City Weather was a really small website when Harvey came out, and after it we were something else. And we saw so much PTSD after Harvey from when it would start raining heavily. Like people were concerned about, would this happen again? Was this another flooding event? So we created a flood scale. Actually, Matt, my partner, did a lot of the work on that. So where we have stage 1 through stage 5 to help people set expectations for flooding events. And now, since we've created the flood scale, we've never had a stage 4 or 5 flood forecast. So I'm not taking any credit for that, but maybe we should get some credit on it. So that's inland flooding, and I think we all have a pretty good sense of what that means, and it's pretty scary, but it's not the scariest part of a hurricane for me. So the second threat is damaging winds, and this for me is really what I lay up at night thinking about. So the Houston area has not seen a major windstorm since 1961, Hurricane Carla. And Hurricane Carla was like 100 miles down the coast. So like we did not get like the worst of it here in Galveston or in Houston. And we have had some recent hurricanes, right? We had Beryl last year. We had Ike. But, you know, these were not crazy windstorms. If you look at the track of Ike, and in Galveston would know it better than anyone, the eye wall came in just to the east of where we're sitting, or in my case, standing. And so the strongest winds from Ike were on the right side of that. So it was over Galveston Bay and Bolivar Peninsula. And most of the Galveston-Houston region saw sustained winds of 60 to 90 miles per hour, which, hey, no picnic. And Beryl was like really a nasty storm too last year. But I got to tell you, it can be a lot worse than that. And does anyone remember how long the power was out after Ike? It was like 2 weeks for a lot of people. And it was those winds. It's just a little preview we're going to talk about with a storm like 1900 hitting here. Okay, so Ike. Okay, so Beryl. Now Beryl was really interesting because first of all, forecasters like myself, we did a pretty bad job. But second of all, I don't think I woke up that morning expecting winds like we saw in the Houston area, right, from Beryl. And it was really interesting because the storm was just in the process of beginning rapid intensification as it made landfall. And so it had all this momentum spinning up, and it took some time for that to weaken. And the other thing is, like, the track you see there is just to the west of the Houston area. So, like, it's just about the worst possible track for strong winds over Galveston and Houston. So it really punched above its weight. And I got to tell you, if it had had 24 more hours more over water, that would have been a really scary storm. We're probably looking at least a Category 3 storm, you know, same track, bringing those winds. So it was pretty bad, but I kind of feel like we dodged a bullet with Beryl because it kind of crossed the Yucatan Peninsula and then made a beeline for Texas. But again, like, the winds from Beryl were less from a lot of parts of Houston than Ike. And again, serious power issues, obviously. The other thing is I wanted to talk about was wind load versus wind speed. And it turns out that if you have a 70 mile per hour wind and increase up to 100 mile per hour wind, it's not linear in the terms of the force of that wind. It's actually cubed. So it's multiplied by itself and multiplied by itself. So the damage, the difference between like an 80 mile per hour storm and a 100 mile per hour storm is actually really, really significant in terms of the force you're putting on structures, on trees that fall into power lines. So, you know, a little more wind matters a lot. And then finally, storm surge. People in Galveston here will be certainly familiar with Ike's damage. That's a picture of Bolivar Peninsula. It's a great ad for building your house to code. There were other houses in that picture, of course, before the storm. So storm surge is just the amount of water being pushed by a circulation above the astronomical tide. And obviously, you get a much stronger surge on the side where the winds are blowing into shore, right? Because those winds are pushing the water. And half of all deaths attributed to hurricanes or tropical storm come from storm surges. I know a lot of people are really concerned about tornadoes during a hurricane, but those don't account for much death. It's storm surge, inland flooding, wind. It's actually chainsaw use after storms is a major cause. I certainly don't touch a chainsaw, although I've had some trees in my yard the last few years. I call it professional. So here's just a picture of storm surge. It's pretty intuitive on what it means, but it really actually matters a lot. Like if the storm is making landfall with the tide, that can really goose the storm surge by several feet and make a big difference. And then this is just a sort of a map showing areas of the region that are most vulnerable to storm surge. Galveston obviously is protected up to a certain elevation by the seawall, which was built after the Great Storm. But there's lots of the region is vulnerable, and I think for the purposes of our talk, it's really interesting to me what's going on the west side of Galveston Bay, where you have fast-growing areas like League City that don't have a seawall, don't have an Ike Dike, don't have a storm barrier, may never have a storm barrier. We'll see what happens. I mean, it's been 17 years. Can I do the math? 17 years since Ike, and we've not built any kind of storm wall. So I'm a little skeptical that it's ever going to happen, although it continues to be talked about. So just a few words about prevention, because it really ties into what I want to talk about tonight with the Great Storm, is that there are things that as a homeowner you can do to protect yourselves, right? Like when you're buying a house, you can check, is it in a floodplain, right? And can I buy flood insurance? And do I have some means of putting storm windows up, right? Plywood or actually dedicated windows. But there's other things like storm surge. Like you can build your house up on stilts, but to really protect areas from flooding, like you need the seawall, or you need a third detention basin in the greater Houston area, or you need wider bayous. So it's like there's an element of personal responsibility in preparing for heavy rain, storm surge, and winds, but also you need government to solve these problems, or Houston and Galveston become less livable places. So it's not like you can protect yourself from hurricane, buy a house in Austin, right? All right, so let's go back and address the question is, okay, what would happen if the Great Storm hit Galveston today? It was interesting. A firm called Dodson Associates modeled 100 storms, basically varying power, speed, and landfall, and the one they studied the most was a Category 4, so like the Great Storm, hitting San Luis Pass, which is just about the worst case scenario for Galveston, for where we are right now. So it could happen, and I hate to say it, looking at those dates, we're kind of due, but in the last 150 years, it happened in 1900, 1915, and 1961. And it hasn't happened since then. And that's 6.5 decades. So, I mean, I got to find some wood here to knock on, but hopefully it doesn't happen, but historically it has, right? So let's look at the three threats that we talked about earlier. So we talked about inland rain. And the interesting thing is when you look at inland rain, there's really no difference in the threat from a tropical storm or a Category 5 hurricane. They both can be very efficient rain producers. And that's unlike the other two threats we're going to talk about. The strength of the hurricane matters a lot. So, we learned this lesson pretty clearly with Allison in 2001. But basically, it comes down to how fast is the storm moving. So if it's a fast-moving Category 5, I'm not really worried about inland rainfall or heavy rainfall. I'm a lot worried about more other things. So yeah, inland rainfall, always a threat. And obviously, if you're dealing with storm surge, you don't want to get 10 inches of rain, right? Because that just exacerbates the problem, and it pushes all the bayous into the land when you're trying to get the water into the bayous to go out to Galveston Bay. So it's a threat, but it's not the one that I think we really need to be too concerned about. This is the one we do. So the storm they modeled was a Category 4, so that's 131 to 155 mile per hour winds at landfall. Okay? So we talked about how the winds, the force of the winds is cubed relative to the speed. So you want to talk about, going from Ike at 80 miles per hour, which was really like the strongest winds anywhere in the Houston metro area, to 120 mile per hour winds. Like, that's the kind of thing that keeps me up at night. Those are massively devastating winds, and it would really, I worry a lot because it would change this community forever, I think, or for a very long time. So if you think about Ike, it caused 2 weeks of power outages. The storm would knock out power for weeks or more likely months, right, for some parts of Houston. So I've been writing about hurricanes for a long time, quarter of a century or longer in the Houston area. And there's just been 2 times in my life doing that where I've really, really had the cold sweats at night, right? The first of these was Hurricane Rita, which I imagine some people in this room sat in a car for a long time 20 years ago, just about this time. And there was a time 3 days out where that storm was Category 5 in the Gulf, looked like it was coming right to Houston, and it was terrifying. Like, I understand why people left. I wish the evacuation had been coordinated, and I wish there had been some planning into actually how to evacuate before then by the cities and counties. But it was okay to be scared about Rita because I was scared. And the other time I've really been concerned about with winds was 5 years ago with Hurricane Laura. People remember Laura? I mean, that was another one that sort of was out there, and it looked like it might turn. And anyway, that's it. So so wind damage is really and the reason why it concerns me so much is there's really no precedent, I think, in the Houston area. Like, we kind of know what a storm surge is after Ike. Look, it could have been worse, and we're going to talk about that. We certainly know what a bad flood is, but we don't know what a bad windstorm is. And you think about what was here in 1961 versus what's here today in this region, and there's just no comparison. So anyway, storm surge. So the seawall now is 17 feet high in Galveston. So you would need a really gnarly surge of about 20 feet to really cause serious problems here. And the storm in 1900 would have produced something like that. And then, of course, you would get water coming in behind, right, from the bay to Galveston. And there's just all this development up the east side of Galveston Bay, Texas City, League City, Clear Lake, lots of communities there. They're certainly 17 feet or below sea level. And that study I talked about where they looked at the San Luis Pass landfalling hurricane found that 600,000 homes in Harris County would flood from storm surge. So, it's lots of vulnerabilities. And again, if Ike had made landfall at San Luis Pass, a lot of this would have come to be. But obviously it didn't. It came in a little further east. And so this, again, is where you would really need to call a good evacuation, because if people don't leave from a storm surge like this, it's deadly. But it's not just lives. It's the ship channel has, of course, all of this petrochemical industry, right, which fuels a lot of our economy. But a lot of those facilities, plants, are built at about 15 feet, 12 feet, 17 feet. And so if you think about how a surge works, it would kind of funnel water into Galveston Bay and then even up the ship channel. So we're talking about, potentially an environmental catastrophe from that kind of a storm surge hitting Galveston Bay. And then you think about 2 of the 4 largest petroleum refining facilities are in there, in the greater Houston area, on the ship channel or near the ship channel. You're not going to have electricity. Gas will be $10 a gallon. I mean, it would be really a bad situation. So yeah, like not to sugarcoat it, because a storm like 1900 hitting today would profoundly affect the lives of millions of people, and it would have ramifications across the country through energy prices and chemical prices and lots of other different things. It would be, we just have not experienced anything like that in our lifetimes. Harvey was bad. I mean, it was really bad, like tons of damage. But for the vast majority of the community, once the waters receded, life for a lot of us went back to normal, and we were able to surge help to the areas that were hard hit. You know, if you get a storm where you have surge and wind damage, it's just the recovery is going to be so much more painful and so much longer. So yeah, I mean, storm 1900 hitting today, bad, very bad. We don't want it. Okay, so we've got a few minutes, and I do want to take questions on anything you'd like to ask. But I wanted to first address, because the most common question we get on Space City Weather after when is it going to rain at my house is, which model should we trust? So last year in July, when Beryl absolutely blew up into a Category 4 hurricane in the northern Caribbean Sea, this was like the different modeling outcomes we were looking at. So when those knuckleheads on Space City Weather were saying, well, we think it's probably going to go into Mexico, this is what we're looking at. Not that one or two models that showed it coming up toward Houston. So there is no absolute answer about which model you should trust, because you shouldn't trust any of them. Right? So that's probably how you're feeling now about me. But I do want to give you a little bit of context. So okay, so the cheat code is to just look at the National Hurricane Center forecast, because those guys and gals are outstanding forecasters, and I'm here to tell you, their only motivation is to be accurate. Like, I have never sensed any political leanings from them. They don't wish cast storms. The only thing they're a little bit biased is that they don't change their forecast rapidly in response to a changing models. So they don't want like a windshield wiper effect with their forecast. They're a little bit conservative in how quickly they'll adjust their forecast. But aside from that, their money, and these are the trends and errors over time of the official track forecast. So it used to be that, in 1990, a 2-day forecast had an error of about 200 miles, and now that error is under 50 miles in terms of the position of the storm. And the 5-day error used to be like 300 miles, and now it's less than 150 miles. So the trend lines are good, and their accuracy is really quite good. The problem with that, of course, is that 30 miles really matters, right? San Luis Pass, Bolivar Peninsula, huge difference. So it's great, but we'd like it to be better. And the problem is there's always going to be some inherent uncertainty, right? There are errors. So you still want to know, well, what's the best model? This is a really, really busy chart. But if you look at the bottom line, it's the black line. That's the official forecast. So that's the error in 48 hours, for the last 3 decades, basically comparing the official track forecast with all the different models. So basically at the end of the season, they look at how did this model do, how did this model do, and just sort of sum it all up. And if you look a little closer, I know it's bright in here. Believe me, the sun's in my eyes. But there's little boxes and stuff at the bottom near the official forecast. Those are called consensus forecasts. So that's basically an average of some of the better models trying to address some of their known biases. So the official forecast is usually the best, but sometimes the consensus forecasts are as good or better. And then above that, you see dots and triangles and things like that. Those are individual models. So on average, the people do the best. The people are looking at consensus models and then sort of drawing, using their own knowledge on top of that. But basically, an average of the models is the best. Okay, but you still want to know, right? Tell me the answer. Well, okay, this is a super busy chart, but I just pulled it down today, and it's an anomaly correlation chart. Basically, it means how accurate is this? So, like, you know, is it 99% accurate? Is it 95% accurate at the bottom? So you want to be the highest model. You want to be the top model in there because you want to get as close to 100% accurate as you can. The red line is the European model. So that is the best model in the world today, bar none. The US model, NCEP, is in green. It's not great. You could make the case that the UK model is better, that Japan has a model as good or better. China, Canada is competitive. So, like, this was before we cut funding for the National Centers for Environmental Prediction. That's what NCEP stands for. And it doesn't, that chart does not have AI models on it, which are completely different than physics-based models. In fact, they don't do any physics at all. You could run it almost on a laptop, but they're really good. Like, they're, in some cases, they're as good as the European model. So we're just kind of at the beginning. We've been doing it for a couple of years, looking at the output from the AI models versus the physics-based models to see what does well where and what doesn't quite do as well in other locations. But it's very promising. So as over the last 20 years, as computers have gotten more powerful and we've gotten better at collecting data about atmospheric conditions, you know, we do everything from weather balloons, so like now airplanes have sensors on them that collect data as they're taking off and landing to get atmosphere profiles. We've gotten much better at taking that data and real time and ingesting into the models. So the forecasts have gotten a lot better over time, and it'll be interesting to see if they continue to improve, especially as we have the AI outputs to look at. So the answer is, if you're looking at a forecast, you always would rather be where the European model isn't bringing the storm, because it's probably right 60% of the time, and the American model is probably right 40% of the time. The problem is you don't really know until after the storm. The other thing to just consider, and I think I'm going to wrap up here pretty soon because I want to take questions, is you've got all kinds of different models, and you really got to know the difference, right? You've got the global models that look at weather all around the world. You've got hurricane-specific models that look just like at a specially embedded system to forecast that. You have intensity models that just measure how strong a storm we get. You've got, on those spaghetti charts, you've got some things that aren't even models, and you really should ignore. You've got storm surge models, and then you've got local models that we look at to try to determine if it's going to rain at your house. Okay. So just finally, this year, oh, and I wanted to say a word too. I was asked to say, well, what's your prediction for the hurricane season? Hurricane season for us is almost over. It's not over yet. Nope. So we've got about 2 more weeks where we really need to be concerned. And I'm watching like the Caribbean Sea, because I think something may form there in the next week or so and could lift north. But it's looking really good for us. And so, but anyway, for us, I mean Texas. So National Hurricane Center has operated pretty much as normal this year. We have seen some staff shortages in places, including our local forecast office just up the road in Dickinson. We have not really had to have many hurricane hunter flights this year because there just have not been that many threats. But there was concern about fewer of those. We've had less weather balloons, and we have seen that in some of our high-resolution modeling. We've seen the impacts of of weather balloons. And interestingly, the state is now considering funding some weather balloon deployments to get better data as the federal government cuts back, and I think that's great. We really need that, especially after the Kerrville flooding. That kind of data is very valuable. And I talked about the GFS model, which really, as I say, even before this year was not among the highest performing in the world, and actually we've seen some degradation. And so I think that's a real concern. It should be.